Welcome to Milky Narratives. Beyond the noise of everyday life lies a universe of endless wonder. Tonight, we leave Earth behind and journey into the depths of space, where ancient stars, distant worlds, and cosmic mysteries await. Let's begin. 1. The planet that orbits inside a dead star's shadow. Imagine living on a world where your sun is already gone, and yet every day still begins beneath the faint light of its ghost. At first, that sounds impossible. After all, a planet needs its star. The star provides warmth, light, energy. Without it, surely the story must come to an end. We tend to think of a solar system the way we think of a family. The star is the parent. The planets are its children. If the parent disappears, the family falls apart. For a long time, astronomers believed something very similar. When a star finally exhausted its nuclear fuel, its planetary system was expected to become little more than a graveyard drifting through space. The inner planets would likely be destroyed, the outer ones scattered into darkness. It seemed like a perfectly reasonable ending. But as we have discovered time and time again throughout our journey, the universe has little interest in endings that are simple. Instead, it quietly writes another chapter, one that begins after the light has already faded. To understand how such a strange world could exist, we first need to appreciate something remarkable about stars. A star spends nearly its entire life performing a delicate balancing act. Deep within its core, hydrogen atoms collide with unimaginable force. Those collisions trigger nuclear fusion, releasing extraordinary amounts of energy. That energy pushes outward. Gravity pulls inward. For billions of years, those two forces remain almost perfectly balanced. It is a quiet equilibrium that allows stars like our sun to shine steadily across immense stretches of cosmic time. Every sunrise on Earth, every growing forest, every drop of rain, every heartbeat in every living creature has depended upon that invisible balance inside a star nearly 150 million kilometers away. But no balance lasts forever. Eventually, the star begins running out of hydrogen. The outward pressure weakens. Gravity slowly gains the upper hand. The star changes. It swells into a red giant, growing hundreds of times larger than before. Its outer layers expand across the planetary system like an enormous wave of fire. Nearby worlds are consumed. Others are scorched beyond recognition. For millions of years, the system becomes almost unrecognizable. If intelligent observers happen to witness those final ages, they might believe everything was ending. And in one sense, they would be right. Yet nature rarely destroys without also transforming. As the aging star sheds its outer atmosphere into space, magnificent clouds of glowing gas drift outward, creating one of the universe's most beautiful sights. From a distance, these colorful shells resemble delicate flowers suspended among the stars. Astronomers call them planetary nebulae, a name inherited from centuries ago, despite having little to do with planets themselves. At the center remains something astonishing. The star has not completely vanished. Its enormous outer layers are gone. Its brilliant golden surface has disappeared. What remains is only the exposed core, a white dwarf. Imagine compressing roughly half the mass of our sun into a sphere no larger than Earth. The result would be almost unimaginably dense. Gravity at its surface would be hundreds of thousands of times stronger than Earth's. A single teaspoon of its material would weigh as much as a mountain. Yet, despite its incredible density, a white dwarf is surprisingly small. Seen from a surviving planet far away, it would no longer dominate the sky as the old star once did. Instead, it might resemble an intensely bright jewel suspended in darkness. Tiny, brilliant, almost motionless, it would still shine. Not because fusion continues, its nuclear fire is over. Instead, the white dwarf slowly releases the enormous heat stored during its long lifetime. It is, in a sense, cooling down. A cosmic ember left behind after an unimaginably long fire? That cooling process is extraordinarily slow. Not thousands of years, not millions, not even billions. White dwarfs may continue glowing for trillions of years before finally fading into complete darkness. In fact, the universe itself is not yet old enough for a single white dwarf to have finished cooling entirely. Somewhere tonight, every white dwarf ever created is still quietly radiating the leftover warmth of ancient stars. Which brings us back to our mysterious planet. Could a world survive all of that? Against intuition, the answer appears to be yes. Not every planet is doomed when its star dies. Those orbiting close to the star are unlikely to survive the violent red giant phase, but worlds much farther away may endure. As the star loses mass, gravity weakens slightly. The surviving planets drift outward into wider, slower orbits. Yet, they remain bound to the stellar remnant. The family changes. It does not disappear. Imagine standing on one of those distant survivors. Your sky would be unlike anything humanity has ever known. The star that once flooded the heavens with warm yellow light has become something entirely different. Daylight would be dim, quiet. The sky might never achieve the brilliant blue familiar to Earth. Instead, it could remain wrapped in a perpetual twilight, illuminated by the pale white glow of an ancient stellar ember. The landscape would seem almost dreamlike, mountains casting impossibly long shadows, frozen valleys stretching toward the horizon, a silence that has lasted for billions of years. Yet, the white dwarf would still hang above the landscape every day, a reminder that even dead stars leave echoes behind. In many ways, it would resemble visiting the ruins of an ancient civilization. The magnificent city has vanished. Its bustling streets are empty. Its people are long gone. Only quiet monuments remain, telling the story of what once existed. A white dwarf is much the same. It is the memory of a star, the final chapter written in light instead of stone. Perhaps the strangest thought is this. From the perspective of any surviving planet, nothing dramatic happens overnight. The transformation unfolds so slowly that no single generation, if life somehow existed there, would witness the complete change. The star would brighten, expand, cool, collapse, all over timescales so immense that civilizations could rise and disappear many millions of times before noticing significant differences. The end of a star is not an explosion in the way we often imagine. For stars like our sun, it is more like a long sunset, lasting hundreds of millions of years. The light grows softer, the colors shift, the sky changes almost imperceptibly, until eventually, the familiar sun becomes a tiny white lantern in an enormous sea of darkness. Could life exist on such a world? That remains one of astronomy's most fascinating questions. At first glance, the answer seems unlikely. A white dwarf produces only a fraction of the energy once generated by its parent star. Any surviving planet would almost certainly become far colder than before. Oceans might freeze, atmospheres could collapse, entire ecosystems might disappear. Yet nature has surprised us before. Life on Earth thrives around deep-sea hydrothermal vents where sunlight never reaches. Microorganisms survive inside Antarctic ice. Others flourish in acidic lakes, beneath crushing pressures, and within rocks kilometers below the surface. Again and again, biology has proven remarkably adaptable. Perhaps somewhere around a distant white dwarf, life has also found a way to endure. Not beneath a blazing young sun, but beneath the quiet glow of its ancient ghost. If so, the inhabitants of such a world would grow up believing their tiny white star had always looked that way. They might never know that billions of years earlier, it had once filled the sky with golden light. Their myths would speak of a pale eternal sun. Their calendars would measure time beneath its gentle glow. Their scientists, much later, might eventually uncover the truth buried within the physics of stellar evolution. they would discover that their quiet little sun had once been a giant, that their peaceful home had survived one of the greatest transformations any planetary system can experience, and perhaps they would stand beneath that faint white sky with the same feeling that we experience tonight. The realization that the universe is far more patient than we are. Stars are born, stars die, planets survive, entire worlds continue circling long after the brightest chapter of their history has ended. It is a comforting thought in its own quiet way, because it reminds us that endings in the universe are rarely absolute. More often, they are simply moments when one story quietly becomes another. 2. The worlds that never finished forming. Some planets may have spent billions of years trapped between becoming something extraordinary and never quite getting there. We often imagine planets as finished worlds, solid, complete, permanent. When we picture Earth, Mars, or Jupiter, we rarely think about the countless millions of years they spent slowly assembling themselves from clouds of dust and gas. To us, planets simply exist, as though they have always looked the way they do today. But the universe is remarkably patient. Nothing appears all at once. Stars are built one atom at a time. Galaxies grow through countless collisions. Even mountains rise grain by grain over unimaginable stretches of time. Planets are no different. They begin not as worlds, but as dust, tiny particles drifting quietly inside enormous disks of gas surrounding newborn stars. Each grain is smaller than a grain of sand. By itself, it seems almost meaningless, yet gravity has a peculiar talent. It rewards patience. 2 grains collide. They stick together. Soon they become pebbles. Pebbles become boulders. Boulders become mountain-sized objects. Eventually, gravity becomes strong enough that these growing worlds begin pulling in even more material. Slowly, almost imperceptibly, a planet is born. Or at least, that is how the story usually goes. But what if the story never reaches its ending? What if something interrupts the process? Imagine an artist working on an enormous painting. The first outlines are complete. Colors begin filling the canvas. Details slowly emerge. Then, suddenly, the artist walks away. Not because the painting failed, not because it was destroyed, simply because time ran out. The unfinished masterpiece remains exactly as it was, suspended forever between beginning and completion. Astronomers increasingly suspect that something similar happens throughout the galaxy. Not every planet succeeds in becoming what it was meant to be. Some may spend billions of years caught between different stages of planetary evolution. Too large to remain ordinary rocks, too small to become fully developed worlds. Their growth interrupted by events beyond their control. One of the greatest challenges facing young planets is competition. A newborn planetary system is a surprisingly crowded place. Dozens, perhaps hundreds, of growing worlds compete for the same limited supply of gas and dust. Some begin forming slightly earlier. Others happen to occupy more favorable regions of the disk. A small advantage at the beginning can grow into an enormous difference later. Much like young trees competing for sunlight in a forest, the earliest or luckiest planets gather more resources. Their gravity strengthens. They grow faster, which allows them to attract even more material. Meanwhile, neighboring worlds slowly fall behind. Eventually, the giant planets consume much of the surrounding gas. Powerful stellar winds begin blowing the remaining material away. The enormous disk that once surrounded the young star gradually disappears, and with it, the opportunity to continue growing. Some planets simply run out of building material, not because they finished, but because the universe closed the workshop before construction was complete. These unfinished worlds may remain almost exactly as they were for billions of years, frozen snapshots of planetary childhood. Astronomers sometimes refer to certain objects as planetary embryos or protoplanets. These are worlds that began forming but never fully completed the journey. Our own solar system preserves evidence of this ancient construction site. Between Mars and Jupiter lies the asteroid belt. At first glance, it may appear to be nothing more than scattered rocks. But many scientists believe those countless asteroids represent the remains of a planet that never existed. Not because it exploded, but because it never had the chance to finish forming. Jupiter's immense gravity continually stirred the region, preventing the material from peacefully gathering into a single world. The result is an enormous collection of fragments, pieces of a story interrupted before its final chapter. Perhaps somewhere among distant stars, entire planets remain trapped in similar circumstances, larger than any asteroid, smaller than fully developed worlds. Their surfaces scarred by ancient collisions that never stopped. Their interiors only partially differentiated. Their histories permanently unfinished. Even giant planets can experience something similar. A growing gas giant must accumulate enormous quantities of hydrogen and helium before the surrounding disk disappears. Timing is everything. If the gas vanishes too early, the planet remains forever smaller than it might have become. If it gathers gas too quickly, it may grow into something bordering on a brown dwarf. Every planetary system is shaped by delicate balances. Tiny differences during the first few million years can produce worlds that look completely different billions of years later. It reminds us that the universe is not assembling identical machines. It is conducting countless experiments simultaneously. Every star becomes a laboratory. Every planetary system tells a different story. Some endings are magnificent. Others remain unfinished. Perhaps that is why astronomers are so fascinated by transitional worlds. Certain exoplanets seem to occupy the mysterious space between familiar categories. Too massive to resemble Earth, too small to resemble Jupiter, too dense, too light, too hot, too cold. Almost as though they paused halfway through one evolutionary path before drifting toward another. Nature rarely draws sharp lines. Instead, it prefers gentle gradients. One type of planet slowly becomes another. One possibility blends into the next. The more worlds we discover, the less certain our neat classifications become. Imagine standing on one of these unfinished planets. Perhaps the landscape stretches endlessly beneath a dim red sun. The crust is thinner than expected. Ancient volcanoes froze before completing their final eruptions. The atmosphere never became thick enough to support vast oceans. Massive impact basins remain untouched because no weather has ever erased them. Everything feels incomplete, not ruined, simply unfinished. The planet resembles a sentence ending with an ellipsis rather than a period. Even its gravity might hint at unrealized potential. Slightly stronger than Mars, slightly weaker than Earth. Enough to hold a thin atmosphere, not enough to keep it forever. Over billions of years, that atmosphere slowly escapes into space, one molecule at a time. The world quietly becomes quieter still, its history no longer written by change, but by stillness. There is something strangely beautiful about that idea. On Earth, we often celebrate completion. Finished buildings, finished books, finished journeys. But the universe does not seem particularly concerned with finished things. Every galaxy remains under construction. Stars continue forming. Others continue dying. Continents drift. Mountains rise and erode simultaneously. Nothing ever truly reaches a permanent final state. Perhaps these unfinished planets simply make that truth easier to see. They remind us that creation is not always guaranteed to reach its intended destination. Sometimes, the process itself becomes the final result. And perhaps those interrupted worlds are every bit as valuable to astronomers as perfectly formed planets. After all, unfinished stories often reveal details that completed ones conceal. By studying planetary systems frozen halfway through their evolution, scientists can better understand how ordinary planets, including Earth, came to exist in the first place. The failures become teachers. The incomplete becomes informative. The exceptions reveal the rules. Perhaps somewhere tonight, beneath the quiet glow of a distant star, another world continues orbiting exactly as it has for billions of years, never becoming the giant it might have been, never collapsing into destruction, simply existing in the peaceful middle ground between possibility and completion. It does not know that astronomers are searching for worlds like it. It does not know that its unfinished history may one day answer questions about planets across the entire galaxy. It simply continues its silent orbit, carrying within it the memory of a beginning that never quite reached its end. And perhaps that is one of the universe's gentlest lessons. Not everything unfinished is a failure. Sometimes an unfinished world is simply another beautiful way the cosmos reminds us that creation is not a destination, but an endless journey. 3. The planets that share 1. Endless sky. What if another planet was always hanging overhead, so enormous that it never disappeared below the horizon? When we think about the sky, we usually imagine empty space. The sun travels across it during the day. The moon rises at night. A few bright planets occasionally wander among the stars. Everything else feels impossibly distant. Even the moon, our closest celestial neighbor, lies nearly 384,000 kilometers away. Large enough to inspire poets, close enough to create the tides, yet still small enough to fit comfortably within the palm of your hand when you stretch out your arm. For all of human history, this has been our definition of a neighboring world. Beautiful, familiar, comfortingly distant. But somewhere in the universe, that idea may be completely ordinary. Imagine walking outside your home one quiet evening. You glance upward. Instead of seeing a small moon floating against the darkness, you are greeted by an enormous world dominating nearly half the sky. Its swirling clouds are visible with your own eyes. Mountain ranges stretch across its surface. Great storms slowly rotate over the course of days. Bright polar caps shimmer beneath distant sunlight. It feels less like looking at the moon, and more like standing beneath another horizon suspended above your head. At first glance, such a scene seems impossible. Surely two planets could never remain so close together without crashing into one another. Gravity would pull them together. Their orbits would become unstable. The system would eventually collapse. That certainly seems reasonable. Yet nature has once again proven more creative than our first instincts. The key lies not only in distance, but in movement. Everything in the universe is moving. The Earth races around the sun at nearly 30 kilometers every second. The moon circles Earth at about 1 kilometer per second. The sun itself travels through the Milky Way at more than 200 kilometers every second. Nothing in the cosmos simply hangs motionless. Instead, stability emerges because everything moves together. Imagine two dancers performing an intricate routine. If one suddenly stops while the other continues moving, they collide. But if both follow the same rhythm, maintaining the proper distance, they can dance together gracefully for hours. Gravity works much the same way. Two worlds can remain companions not by resisting gravity, but by constantly falling together. Astronomers already know of many remarkable examples within our own solar system. Consider Pluto and its largest moon, Charon. Their relationship is unlike any other. Charon is so large compared to Pluto that the two objects do not behave like a typical planet and moon. Instead, they orbit a shared center of gravity located in the empty space between them. Neither truly dominates the other. It is almost as though they are dancing together across the darkness. From Pluto, Charon never rises or sets. It simply hangs in the same position in the sky forever. Imagine witnessing such a sight. Every morning, There it remains, every evening, still there. Generations could pass beneath its silent presence without ever watching it climb above the horizon or disappear behind it. It becomes as permanent as a mountain, only infinitely more magnificent. Now imagine taking that concept even further. Instead of a moon, picture another planet, roughly your own size, perhaps even larger. Both worlds locked together through tidal forces, each always presenting the same face toward the other, neither ever turning away. The result would be extraordinary. One entire hemisphere would enjoy an uninterrupted view of its neighboring planet. The opposite hemisphere would never see it at all. Imagine growing up on the side facing your companion world. Children would never experience a sky without it. Poets would write endlessly about its beauty. Artists would spend lifetimes trying to capture its changing colors. Calendars might even be based upon the slow rotation of cloud systems visible on its surface. To them, another planet overhead would seem perfectly ordinary. Travel to the opposite side of the world, however, and something remarkable happens. The giant planet slowly approaches the horizon. Eventually, it disappears, never to return unless you journey back across the planet. For the first time, the sky feels strangely empty. A traveler crossing that invisible boundary might feel as though an entire mountain range had vanished from existence. Perspective changes everything. Even daylight would become more fascinating. If the neighboring world possessed bright clouds or icy regions, enormous amounts of sunlight could reflect toward the surface below. Nights might never become completely dark. The giant companion could illuminate valleys with a pale silver glow far brighter than Earth's full moon. Cloud shadows drifting across the neighboring planet would subtly change the amount of reflected light reaching the landscape below. Entire ecosystems might adapt to this gentle secondary illumination. Some plants could bloom beneath planetary light. Some animals might navigate using the enormous companion overhead rather than distant stars. Life would evolve beneath two worlds instead of one. Then there are eclipses. On Earth, a total solar eclipse is among the rarest and most breathtaking events we can witness. The moon briefly covers the sun. Day becomes twilight. Stars appear. Birds fall silent. The experience lasts only a few precious minutes. On a world sharing its sky with a neighboring planet, eclipses could become far more dramatic. Imagine your companion slowly passing in front of the distant star. Its immense disk gradually blocks more and more sunlight. The landscape darkens. Temperatures fall. Then, for perhaps hours rather than minutes, the world remains beneath the shadow of another planet. Above you hangs not darkness, but the magnificent outline of an entire neighboring world surrounded by a brilliant ring of starlight. Such events might shape entire civilizations, festivals, religions, stories, generations waiting for the great shadow to return. Perhaps children would count the years between eclipses, just as ancient cultures on Earth watched the heavens for rare celestial alignments. Astronomy has always shaped mythology. Different skies would inspire different dreams. Scientists believe that during the chaotic youth of planetary systems, close gravitational encounters were probably common. Some worlds collided. Others were thrown into interstellar space. Still others settled into surprisingly stable arrangements. The universe has had billions of years to experiment. Given enough stars and enough planets, almost every arrangement permitted by physics may eventually appear somewhere. That thought is quietly astonishing. Not because every possibility certainly exists, but because the cosmos is unimaginably large. With hundreds of billions of stars in the Milky Way alone, even rare events become surprisingly common. Somewhere, there may indeed be two Earth-sized worlds locked together beneath the same endless sky, each watching the other through countless generations, each rising nowhere, because neither ever sets. Perhaps civilizations on both planets eventually develop astronomy. At first, they study the stars. Later, they examine the neighboring world overhead. Powerful telescopes reveal oceans, clouds, mountain ranges, maybe even the lights of another civilization looking back. Imagine the first moment one world realizes that the distant lights shining across its eternal sky are not volcanoes, not reflections, but cities. The nearest alien world would not be dozens of light years away. It would be close enough to watch storms move across its surface, close enough to see seasons change, close enough to dream of visiting. The history of both civilizations might become inseparable, not divided by the immense emptiness between stars, but connected by a sky they have always shared. Perhaps they would grow up telling the same stories, wondering the same questions, looking upward with the same curiosity. Because sometimes the greatest distance in the universe is not measured in kilometers, it is measured in understanding. And sometimes, the closest neighboring world may be one that has quietly watched over your entire history from the very beginning. If these quiet journeys through the universe are helping you slow down for the night, consider subscribing and let's continue exploring the cosmos together. 4. The worlds where gravity feels wrong. On some distant planets, simply taking a step could feel like learning to walk all over again. Gravity is one of the few things we almost never think about. It is always there, quietly pulling us toward the ground, keeping our oceans in place, holding our atmosphere close, guiding the moon through its endless orbit. Every movement you've ever made has happened in partnership with gravity. When you stand up from a chair, gravity is there. When you toss a ball into the air, gravity patiently brings it back. Even as you lie peacefully in bed listening to this story, gravity is gently holding you against the earth. It feels so ordinary that we mistake it for something universal. Surely we assume gravity must feel more or less the same everywhere, perhaps a little stronger, perhaps a little weaker, but otherwise familiar. The universe, as it so often does, quietly disagrees. Somewhere among the countless planets of the Milky Way are worlds where every ordinary movement would suddenly become extraordinary, where walking would feel unfamiliar, running would require entirely new instincts, even standing still might feel strangely different. Imagine stepping through the airlock onto one of these distant worlds. The ground looks solid enough. Mountains rise in the distance. Clouds drift overhead. Nothing immediately appears unusual. You take your first step, and instantly, your body realizes something your eyes cannot see. Gravity has changed. If the planet is much smaller than Earth, your first step carries you much farther than expected. Your muscles apply the same force they always have, but the planet pulls back with less determination. Instead of walking, you almost bounce. Every stride becomes unexpectedly graceful. Every jump lasts longer. Landing feels wonderfully gentle. On Earth's moon, astronauts experienced something similar. Although the moon possesses only about 1/6 of Earth's gravity, they quickly discovered that walking normally no longer worked very well. Instead, they developed a peculiar hopping motion that looked almost playful. It wasn't a choice, it was simply the most efficient way to move. Now imagine a planet even smaller. Each leap carries you several meters. Objects thrown into the air seem reluctant to come back down. A simple game of catch becomes an exercise in patience. Even pouring a cup of water behaves differently as the liquid falls more slowly toward the ground. Your own body begins feeling strangely lighter, not because you've changed, but because the world beneath your feet has. At first, it might seem delightful. Who wouldn't enjoy effortless jumps, towering leaps, the ability to lift enormous weights? But after a while, the novelty begins revealing hidden challenges. Our bones evolved beneath Earth's gravity. Our muscles expect constant resistance. Without enough gravitational force, they gradually weaken. Astronauts aboard the International Space Station lose muscle mass surprisingly quickly despite exercising for hours every day. Gravity, it turns out, is not merely something we endure. It quietly shapes who we are. Now imagine the opposite, a world significantly larger than Earth, perhaps twice our planet's mass, or 3 times. The first step would feel entirely different. Your body suddenly seems heavier. Not just your backpack, not just your clothing, every part of you, your arms, your legs, even lifting your head requires noticeably greater effort. Walking becomes exhausting. Running, almost impossible. Each movement demands careful planning. The ground refuses to let go. Jumping becomes almost comical. Instead of soaring into the air, you barely leave the surface before gravity gently but firmly pulls you back down. A staircase that seems ordinary by Earth's standards suddenly feels like climbing a mountain. Simply standing for long periods becomes tiring, not because the air lacks oxygen, but because gravity never stops asking your muscles to work harder. Life on such a planet, if it exists, would almost certainly evolve very differently. Tall trees might be rare. Their own weight would become a constant challenge. Animals could develop shorter, sturdier limbs, broad bodies, powerful muscles. Everything would be built lower to the ground. Not because nature lacked imagination, but because gravity quietly encouraged stability over height. On Earth, the tallest trees rise more than 100 meters into the sky. Perhaps on a heavier world, forests would remain low and dense, branches spreading sideways instead of upward. Mountains themselves might look different. Gravity constantly pulls every rock downward. The stronger that pull becomes, the more difficult it is for mountains to remain tall. Over millions of years, enormous peaks gradually collapse beneath their own weight. The landscape slowly smooths itself. Even geology listens to gravity. Yet on tiny worlds, mountains can become astonishingly tall. Mars offers a beautiful example. Olympus Mons, the largest volcano in the solar system, rises nearly 22 kilometers above the surrounding plains, almost 3 times taller than Mount Everest. Such a colossal mountain could never exist on Earth. Our stronger gravity would gradually pull it apart long before it reached that height. Mars allowed the volcano to keep growing simply because gravity whispered more gently. It is remarkable to realize that even mountains owe their shapes to an invisible force. Gravity becomes the silent sculptor of entire worlds. Even the atmosphere responds. On a small planet with weak gravity, gases escape into space much more easily. Over billions of years, the atmosphere gradually becomes thinner. The sky darkens. The air grows cold. Mars again provides a familiar example. Long ago, it probably possessed rivers, lakes, and a much thicker atmosphere. Today, only traces remain. Gravity simply wasn't strong enough to hold everything forever. Meanwhile, giant planets grip their atmospheres with extraordinary strength. Hydrogen and helium remain bound for billions of years. Clouds hundreds of kilometers thick swirl endlessly above hidden interiors. The weather itself becomes a monument to gravity's persistence. Perhaps the strangest consequence is something we rarely consider: time itself. According to Einstein's theory of general relativity, gravity influences not only motion, but time. The stronger the gravitational field, the more slowly time passes relative to regions experiencing weaker gravity. Here on Earth, the effect is tiny, almost impossible to notice without extremely precise atomic clocks. Yet it is real. Satellites orbiting our planet must constantly account for these tiny differences. Otherwise, GPS systems would gradually become inaccurate. Imagine standing on the surface of an enormously massive planet. Your watch would tick normally. Your heartbeat would feel unchanged. Everything around you would seem perfectly ordinary. Yet compared with someone far away from that powerful gravity, time would be passing ever so slightly more slowly. You would never notice. They would never notice. Only careful measurements reveal the quiet difference. The universe is subtle that way. It hides extraordinary truths beneath ordinary experiences. Perhaps this is one of the reasons gravity feels almost mysterious. Unlike light, we cannot see it. Unlike wind, we cannot hear it. Unlike rain, we cannot touch it directly. We only witness its influence. The falling apple, the orbiting moon, the flowing tides, the bending of distant starlight around massive galaxies. It is an invisible artist whose work fills the universe. Every planet is, in many ways, a different interpretation of gravity. Some worlds pull gently, others hold with astonishing strength. Some allow mountains to scrape the edge of space. Others flatten landscapes beneath relentless weight. Every alien civilization, if any exist, would grow up believing their own gravity feels perfectly normal. Their architecture, sports, music, dance, transportation, even their language might quietly reflect the pull beneath their feet. Only after visiting another world would they realize that something as simple as taking a single step can completely redefine the meaning of home. Perhaps somewhere tonight, beneath unfamiliar constellations, someone is walking across a landscape where gravity feels entirely natural to them. Their stride is effortless. Their world feels perfectly balanced. They have never imagined that elsewhere in the galaxy, another civilization must work harder simply to stand, while others can leap across great distances with a single bound. It is a quiet reminder that the universe changes not only the places we discover, but the very way we experience existence itself. Because sometimes the greatest difference between two worlds is not what we see when we look up at the sky, but what we feel every time our feet touch the ground. 5. The planets born around two different suns. Some worlds never belonged to just one star. Every sunrise unfolds beneath two suns dancing through the same sky. For most of human history, the idea of two suns belonged entirely to mythology. Ancient stories spoke of twin stars crossing the heavens. Poets imagined skies filled with double dawns. Artists painted impossible sunsets where two brilliant lights slowly disappeared beyond the same horizon. It was a beautiful idea, but surely only fantasy. After all, our own solar system has taught us a very simple picture of how planets are born. One star forms at the center of a vast cloud of gas and dust. Around that lonely sun, planets gradually emerge. The arrangement feels so natural that we rarely question it. One star, many worlds. It seems almost like a universal rule. Yet once astronomers began carefully studying the galaxy, they uncovered a remarkable surprise. Our sun is not the most common kind of star. In fact, many stars are not alone at all. They are born in pairs, two young stars emerging together from the same collapsing cloud, bound by gravity from the very beginning. Instead of one sun lighting the heavens, there are two, dancing endlessly around one another. This graceful cosmic dance can continue for billions of years. Imagine watching such a system from far away. Neither star remains perfectly still. Each slowly circles an invisible center of gravity between them. Sometimes they appear close together, sometimes farther apart. Their movement is patient, measured, elegant, a dance that may continue longer than life has existed on Earth. Now imagine the enormous disk of dust surrounding those newborn stars. Inside that swirling cloud, countless tiny grains begin colliding. Dust becomes pebbles. Pebbles become rocks. Rocks become mountain-sized bodies. Eventually, planets begin to form. But unlike Earth, those worlds never know the comfort of a single steady sun. From the very first moment of their existence, they belong to two stars. The process is far more complicated than it might first appear. Every grain of dust feels the gravity of two moving objects instead of one. The entire disk twists and ripples. Regions of calm alternate with regions of chaos. Material is constantly pulled in different directions. For many years, astronomers wondered whether planets could survive such confusion at all. Would gravity simply tear everything apart before a world had time to grow? It seemed entirely possible. Nature, however, had another surprise waiting. In 2011, NASA's Kepler Space Telescope confirmed something extraordinary. A planet called Kepler 16b was discovered orbiting two stars. For the first time, humanity knew with certainty that the famous double sunsets imagined in stories were not merely works of fiction. They existed, not in our imagination, but in reality. Since then, astronomers have discovered many more circumbinary planets, worlds that travel around two suns instead of one. Each discovery gently expanded our understanding of what planetary systems can become. Imagine standing on one of those distant worlds. Morning begins differently than it does on Earth. Perhaps one sun has already risen, while the other still hides below the horizon. Golden light stretches across the landscape. Long shadows drift over valleys and mountains. Then, a second sunrise begins. Another brilliant star slowly climbs into the sky. The colors change. The brightness increases. Two suns now illuminate the world together. Every object casts two shadows, one darker, one softer. As the stars continue their graceful dance, those shadows slowly shift, crossing one another in intricate patterns throughout the day. No painter on Earth has ever witnessed such light. No photographer has ever captured it. Only the universe has seen those mornings. Sunset becomes equally mesmerizing. Sometimes one star disappears first. Twilight begins, yet daylight refuses to end. The second sun continues shining. Only later does it finally sink below the horizon, leaving the world beneath unfamiliar constellations. On other days, the stars may set almost together, producing breathtaking displays of overlapping colors unlike anything our atmosphere has ever created. Imagine how differently time might feel beneath two suns. Calendars would become wonderfully complicated. On Earth, our seasons arise because our planet tilts slightly as it circles one star. But on a circumbinary world, the constantly changing positions of two stars create subtle variations in temperature and illumination. Some years might be slightly warmer, others cooler, not because the planet itself changes, but because the two suns never repeat exactly the same dance in quite the same way. The rhythm of the heavens becomes richer, more intricate, more unpredictable. Ancient civilizations living there would likely become extraordinary astronomers. They would need to understand the movements of two suns rather than one. Their earliest calendars might require careful observations stretching across generations. Stories and legends would naturally emerge from the elegant choreography overhead. Perhaps one sun would represent youth, the other wisdom, one symbolizing beginnings, the other endings. Cultures often shape their beliefs around the sky they inherit. Different heavens inspire different myths. Even the appearance of daylight could change depending upon the stars themselves. If one star glowed slightly redder than the other, morning might begin with warm amber light, before gradually becoming whiter as the second sun climbed into view. Clouds could display colors that Earth never experiences. Mountains might glow differently depending upon which star illuminated them. The landscape itself would possess two distinct personalities throughout the course of a single day. Then there is night. Would it ever become completely dark? That depends upon the arrangement of the stars. Sometimes both suns may disappear together, allowing countless distant stars to emerge. Other times, one star lingers above the horizon while the other has already set. Twilight stretches onward. Darkness patiently waits its turn. The distinction between day and night becomes softer, less absolute. Perhaps that gentle transition shapes the daily rhythms of life itself. Plants, animals, even intelligent civilizations might develop entirely different concepts of morning and evening. One fascinating question continues to intrigue astronomers. Could Earth-like planets exist in these remarkable systems? The answer appears increasingly encouraging. Computer simulations suggest that stable orbits are entirely possible, provided the planet remains far enough away from the two stars. Instead of being pulled apart by competing gravity, the world simply circles both stars together. The pair behaves almost like a single gravitational source. The dance remains beautifully balanced. Indeed, several potentially rocky planets have already been discovered in binary systems. Some reside within regions where temperatures might allow liquid water to exist. Whether life has emerged, there remains unknown. But physics offers no obvious reason why it could not. Imagine the first living organism opening microscopic eyes beneath a sky containing two suns. To it, nothing would seem unusual. Two stars would simply be normal. Only much later, if intelligent observers evolved and eventually discovered solitary stars elsewhere in the galaxy, would they realize how unique their home truly was? Perspective shapes everything. We often think of Earth as ordinary because it is familiar. Yet to someone born beneath twin suns, our single golden star might seem strangely lonely. Astronomy has repeatedly reminded us that nature enjoys variety far more than repetition. Some stars live alone, others travel in pairs. Some planets orbit one sun, others circle two. Some systems contain giant worlds, others tiny rocky companions. The galaxy is less like a factory producing identical planetary systems, and more like an artist endlessly experimenting with new combinations. Every discovery teaches us to expect the unexpected. Perhaps somewhere tonight, beneath two slowly drifting suns, gentle winds are crossing an alien landscape. Twin dawns continue unfolding just as they have for billions of years. Two shadows quietly stretch across ancient mountains. Two reflections shimmer upon distant oceans. And high above, two stars continue their timeless dance, never realizing that on a small blue planet many light years away, another civilization is only beginning to imagine what it must feel like to call such an extraordinary sky home. 6. The ancient worlds, older than almost everything, long before Earth existed, before our sun was even born. A handful of planets may already have been quietly circling ancient stars. It is easy to think of Earth as ancient. After all, our planet is about 4.5 billion years old. That number is so enormous that it almost escapes our imagination. 4.5 billion years, long before dinosaurs, long before oceans filled with fish, long before the first tree reached toward the sky. Even the earliest bacteria had not yet appeared. Earth has existed for almost 1/3 of the universe's entire history. Surely, that must make it one of the oldest worlds. But the universe has a remarkable habit of gently reminding us how small our perspective truly is. Because somewhere beyond the reach of our eyes, there are planets that were already ancient while Earth still did not exist. Worlds that may have completed billions of orbits before our sun first began to shine. Imagine visiting such a place. The mountains beneath your feet could have witnessed the births and deaths of countless neighboring stars. Entire galaxies may have slowly changed shape while that quiet world continued circling its parent sun. Civilizations on Earth measure history in thousands of years. Geologists think in millions. Ancient planets think in billions. To understand how such extraordinary worlds became possible, we must travel back to the earliest ages of the cosmos. The universe began nearly 13.8 billion years ago. At first, it was astonishingly simple. Hydrogen, helium, a few tiny traces of lithium. That was almost everything. There were no rocky planets, no oceans, no mountains, no forests, not even the carbon needed to build living cells. The ingredients simply did not yet exist. The first generation of stars formed from those simple elements. They lived fast. Many were enormous. far larger than our own sun. Inside their blazing cores, something extraordinary happened. They became cosmic furnaces. Hydrogen fused into helium, helium into carbon, carbon into oxygen. Then heavier and heavier elements followed: iron, silicon, magnesium, calcium. Nearly every atom inside your body today was forged within stars like these. When those giant stars reached the ends of their lives, many exploded as spectacular supernovae. Their final moments scattered freshly created elements across surrounding space. Only then could rocky planets begin to form. In a sense, the first planets had to wait patiently for stars to manufacture the materials from which worlds are built. Earth itself is made from ancient stellar ashes. So is every mountain, every grain of sand, every living creature. We are, quite literally, assembled from the remains of stars that lived before our own sun. Yet those first generations of enriched stars appeared billions of years before the solar system. Around some of them, planets almost certainly formed, worlds unlike anything Earth had yet become. One remarkable example has fascinated astronomers for decades. A planet known as PSRB 162-0-26b, sometimes affectionately called Methuselah, is estimated to be around 12.7 billion years old. If that estimate is correct, this extraordinary world formed when the universe itself was less than 1 billion years old. To appreciate that timescale, imagine compressing the entire history of the universe into a single calendar year. Earth would not appear until early September. Dinosaurs would arrive around Christmas. Human civilization would occupy only the final few seconds before midnight on New Year's Eve. Methuselah would have been present almost since January. Its story began while the universe was still remarkably young, while galaxies were only beginning to mature, while countless stars that illuminate our skies tonight had not yet formed. It has quietly survived nearly everything the cosmos has experienced since then. That thought carries a certain quiet beauty. Imagine standing upon such an ancient world. Every sunrise would illuminate landscapes older than almost anything we know. The rocks beneath your feet might have remained undisturbed for billions of years. Mountain ranges could have risen and eroded several times over. Entire oceans may have appeared, disappeared, and perhaps returned again. The planet's history would be measured not by civilizations, but by the evolution of galaxies themselves. Astronomers believe some of the oldest planets formed in environments very different from our own. Many ancient stars contain fewer heavy elements than the Sun because they formed before the universe became richly enriched by generations of exploding stars. For a long time, scientists wondered whether such stars could produce planets at all. After all, rocky worlds require silicon, iron, oxygen, magnesium, and many other elements forged inside earlier stars. Would there simply be too little material available? Surprisingly, the answer appears to be more encouraging than once believed. Even relatively small amounts of heavy elements may be enough to build planets. Perhaps not planetary systems exactly like ours, but worlds nonetheless. The universe once again proves remarkably efficient. It wastes very little. What makes these ancient planets especially fascinating is not merely their age, it is everything they have endured. Our solar system has remained comparatively peaceful. Certainly, there have been asteroid impacts, comets, the slow migration of giant planets early in its history. But overall, the Sun has enjoyed a relatively stable existence. An ancient planet, however, may have experienced events almost beyond imagination. Nearby stars exploding as supernovae, close encounters with wandering stellar neighbors, the slow reshaping of entire star clusters, perhaps even gravitational interactions powerful enough to alter its orbit. Yet somehow, it remained, still circling, still surviving. There is something deeply comforting about that quiet resilience. Astronomers often describe stars as living long lives, but planets, in many cases, may prove even more enduring. Stars eventually exhaust their nuclear fuel. They expand, collapse, fade. Some planets continue orbiting the remnants. Others drift away into interstellar darkness. Worlds, it seems, can sometimes outlive the brilliant stars that created them. In a way, planets become the universe's archivists. They silently preserve memories of cosmic eras that no longer exist. Imagine if rocks could remember. An ancient planet might contain minerals formed beneath skies completely unlike those of today. Its earliest atmosphere may have witnessed the first generations of galaxies growing brighter across the young universe. The constellations above it would have changed beyond recognition over billions of years. Stars come and go. Galaxies rotate. Everything slowly rearranges itself. Only the patient orbit continues. Could life have appeared on such an ancient world? No one knows, but the possibility is profoundly intriguing. If conditions remained stable for billions upon billions of years, life would have possessed an almost unimaginable amount of time to evolve. On Earth, complex multicellular life required roughly 4 billion years to emerge. An older planet might have enjoyed twice that opportunity. Or more. What forms might evolution create, given such immense stretches of time? The answer lies far beyond anything we can presently observe. Yet simply asking the question expands our imagination. Perhaps somewhere tonight, beneath unfamiliar stars, an ancient planet continues its quiet journey. Its sun may now be old, dimmer than before, perhaps even approaching the end of its own long life. Yet the planet remains faithful to its orbit, just as it has for almost the entire age of the universe. It has watched neighboring stars ignite. It has watched others disappear. It has circled through epochs beyond human comprehension. If mountains could tell stories, theirs would be longer than the history of galaxies. And perhaps that is the most humbling thought of all. When we gaze upward, we often imagine ourselves looking into space. But in truth, we are also looking into time. Every distant star is a message from the past. Every ancient planet is a survivor from an earlier chapter of the cosmos. They remind us that Earth is not among the first worlds, nor will it be among the last. Our home occupies only one page in a book the universe began writing billions of years before the sun first rose over a young and empty Earth. And somewhere, in the quiet darkness between the stars, those ancient worlds continue turning with extraordinary patience, still carrying the memories of a universe that was young long before we ever learned to look up. 7. The planets hidden inside cosmic dust. Entire worlds may already exist, completely invisible behind enormous clouds of dust that no telescope can yet see through. When we look up at the night sky, it feels as though we are seeing the universe. Thousands of stars sparkle above us. Bright constellations stretch across the darkness. The Milky Way forms a soft river of light, flowing from one horizon to the other. It is breathtaking, yet it is also wonderfully deceptive, because what we see is only a tiny fraction of what is actually there. Imagine standing in the middle of a dense forest at midnight. A flashlight illuminates the nearest trees. You can make out a narrow path ahead. Perhaps you glimpse a distant hill through the branches. It feels as though you understand the landscape. But beyond the reach of your light, entire valleys remain hidden. Rivers continue flowing. Mountains rise silently in the darkness. Their existence does not depend on whether you can see them. The universe is much the same. Astronomy often feels like exploring that forest with an ever-improving flashlight. Each new telescope allows us to see a little farther, a little more clearly, yet vast regions remain concealed behind enormous curtains of cosmic dust. And somewhere inside those hidden places, entire worlds may already be waiting. The word dust hardly sounds impressive. On Earth, dust gathers quietly on bookshelves. It floats through sunbeams. We wipe it away without giving it much thought. Cosmic dust, however, is something entirely different. It consists of unimaginably tiny particles of carbon, silicates, frozen ice, and heavier elements forged inside ancient stars. Each grain is microscopic, almost insignificant on its own, but gather trillions upon trillions of them together. Stretch them across light years of space, and they become surprisingly powerful. These enormous clouds absorb visible light. They scatter it, they hide whatever lies beyond. To an ordinary optical telescope, they appear almost like great dark walls stretching across the galaxy. It is not because nothing exists behind them. It is because the light cannot escape. In many ways, cosmic dust behaves like thick morning fog. Imagine standing beside the ocean before sunrise. The lighthouse is still there. The cliffs remain exactly where they have always been. Ships continue sailing, yet the fog quietly erases them from sight. Nothing has disappeared, only your ability to see. Throughout the Milky Way, countless stellar nurseries are wrapped inside similar veils. These immense clouds are where stars are born. Gravity slowly gathers gas and dust into denser regions. Temperatures rise. Pressure increases. Eventually, a new star ignites. Around it, leftover material begins swirling into a broad rotating disk. Within that disk, planets begin their own slow journey toward existence. Ironically, the very dust that creates planets also hides them from us. The universe seems almost playful that way. Its greatest workshops are concealed behind their own building materials. For decades, astronomers could only imagine what was happening inside these hidden nurseries. They understood the physics. They saw indirect evidence, but the actual process remained largely invisible. It was like listening outside the walls of a great cathedral while hearing only faint echoes of the music within. Fortunately, light comes in many forms. Visible light is only one tiny part of a much larger spectrum. Some wavelengths, such as infrared light, can travel through dust far more easily. Others, like radio waves, pass almost effortlessly through regions that appear completely opaque to our eyes. As technology improved, astronomers learned to observe the universe using these invisible forms of light. Suddenly, the darkness began revealing its secrets. Infrared telescopes uncovered glowing newborn stars still wrapped inside their dusty cocoons. Radio observatories mapped enormous clouds where future planetary systems were quietly taking shape. Each new instrument became another way of gently lifting the veil. Yet even now, much remains hidden. Some clouds are so dense that even our most advanced observatories struggle to peer completely through them. The James Webb Space Telescope has dramatically expanded our ability to study these regions, revealing breathtaking details that were invisible only a few years ago. But even Webb has limits. The universe is simply too vast, too layered, too patient. There are almost certainly worlds still concealed beyond our present reach. Imagine one of those unseen planets. Perhaps it has already completed millions of orbits around its young star. Mountains may already be rising. Volcanoes may be reshaping the landscape. Storms could be sweeping across its atmosphere. Moons might even be forming around it. Yet, from Earth, it remains completely invisible, not because it is too small, not because it is too far away, simply because an enormous cloud of dust lies between us. The thought is strangely humbling. Entire histories may already be unfolding without our knowledge. Nature does not pause while we improve our telescopes. Stars continue forming, planets continue cooling, galaxies continue evolving. The universe has never waited for observers. Sometimes astronomers detect these hidden worlds without ever seeing them directly. A star may wobble ever so slightly as an unseen planet tugs upon it. A faint gap inside a dusty disk may hint that an invisible world has already cleared a path through surrounding material. Subtle ripples, gentle shadows, tiny changes in motion. Like detectives studying footprints in fresh snow, Scientists often infer the presence of planets from the quiet influence they exert on everything around them. The planet itself remains unseen. Its gravity tells the story. One of the most beautiful discoveries in recent years has been the observation of protoplanetary disks, vast rings of gas and dust surrounding young stars. Some display astonishing dark gaps carved into the glowing material. These empty lanes are widely believed to mark the locations where newborn planets are gathering mass. In a sense, astronomers are watching planets before they fully emerge, not by seeing the worlds themselves, but by watching the fingerprints they leave behind. Imagine standing inside one of those dusty disks. The sky would be unlike anything Earth has ever known. Instead of clear blue daylight or sparkling stars, the heavens might glow softly, with reddish light scattered through billions of microscopic particles. The newborn star could appear hazy, wrapped in shimmering clouds. Far beyond, other young stars would flicker through the dust like distant lanterns in a dense fog. It would be a universe still under construction, nothing fully finished, everything quietly becoming. Perhaps there is something profoundly comforting about that image. We often imagine creation as a single dramatic moment, a beginning followed by completion. But the universe prefers gradual transformations. Stars spend millions of years forming. Planets require millions more. Even galaxies evolve over billions of years. Creation is less like flipping a switch, and more like watching dawn slowly brighten the horizon. Every stage matters, even those hidden from view. Perhaps that is why astronomers remain so patient. They understand that every unanswered question is not a failure. It is an invitation. Every dark cloud conceals another possibility. Every unexplored region whispers that the universe still has stories left to tell. Somewhere tonight, behind one of those immense curtains of cosmic dust, a planet may be witnessing its very first sunrise. Elsewhere, another may already possess oceans beneath skies no telescope has ever seen. Another might still be gathering the final fragments needed to become a world. We do not know. And that uncertainty is part of the beauty, because every time humanity builds a more powerful telescope, the darkness retreats just a little farther, not because the universe changes, but because our understanding grows. The hidden worlds were always there, patiently waiting, quietly circling their stars behind clouds of ancient dust, long before anyone on Earth ever wondered whether they existed at all. If tonight's discoveries are leaving you with a little more wonder, subscribe and join me as we continue uncovering the hidden corners of our galaxy. 8. The frozen worlds waiting for second sunrise. Some planets may spend billions of years locked in darkness, only to awaken when a passing star briefly returns warmth to their frozen skies. When we imagine a frozen world, we usually picture something permanent. A silent planet buried beneath endless ice, its oceans locked beneath kilometers of frozen crust, its mountains standing motionless beneath a sky where nothing ever changes. It feels like the end of a story, a place where time itself has almost stopped. But the universe rarely believes in permanent endings. Sometimes, even the coldest worlds are only sleeping, waiting patiently for something extraordinary to happen. To understand how such a remarkable awakening could occur, we first need to remember something surprising about stars. Although they seem fixed in the night sky, stars are never truly standing still. Every star in the Milky Way is traveling. Our own sun is racing around the center of the galaxy at nearly 220 kilometers every second. Neighboring stars follow their own paths. Some move faster, some slower. Some drift toward us. Others gradually move away. The night sky appears unchanging only because the distances are so enormous. If human beings lived for 1,000,000 years instead of 100, the constellations would slowly reshape themselves before our eyes. Given enough time, every star eventually becomes a traveler. Now imagine a lonely planet orbiting a dim red dwarf star, or perhaps no star at all. Its own sun may have faded, or the planet may have been thrown into interstellar space billions of years ago during the chaotic youth of its planetary system. Without steady sunlight, temperatures slowly fall, oceans freeze, clouds disappear, the atmosphere grows thin, snow accumulates century after century until even mountains become smooth beneath endless layers of ice. Eventually, the world enters a silence unlike anything Earth has ever known. No flowing rivers, no rainfall, no seasons, only darkness, only cold, only time. For billions of years, nothing appears to change. If someone could somehow stand upon its frozen surface, the sky would be breathtakingly empty. The sun is gone. There is no comforting daylight. Instead, countless stars shine with astonishing clarity against perfect darkness. The Milky Way stretches overhead like a luminous river. Galaxies become easier to see than clouds once were. The universe appears unimaginably beautiful and unimaginably cold. Such wandering worlds may seem hopelessly lifeless. Yet astronomers have begun asking an intriguing question. What if they are not completely dead? Deep beneath the frozen crust, heat may still remain. Every rocky planet forms with enormous amounts of internal energy. Collisions during its birth generated tremendous heat. Radioactive elements buried within its interior continue releasing energy even today. Earth itself possesses a molten core more than 5,000 degrees Celsius. That hidden warmth drives volcanoes, earthquakes, and the slow movement of continents. Now imagine a frozen rogue planet wrapped beneath a thick blanket of insulating ice. The surface may be colder than almost anywhere in the solar system. Yet kilometers below, liquid water might still survive. The ice acts almost like a giant winter coat, keeping precious heat from escaping too quickly. Some scientists have suggested that entire underground oceans could persist beneath frozen surfaces for astonishing lengths of time. If so, these worlds may not be lifeless at all. They may simply be hiding their activity where sunlight cannot reach. Then imagine something remarkable happens. Far away, another star approaches, not dangerously close. The galaxy is far too spacious for frequent collisions. But over billions of years, stars occasionally pass within a few light years of one another. Most encounters are gentle, brief. Yet even a distant passing star adds something that has been absent for ages: light and warmth. At first, the change would be almost impossible to notice. The newcomer appears as an unusually bright star. Night remains night. The frozen landscape continues sleeping beneath endless ice. But century after century, the visitor slowly grows brighter. What once resembled an ordinary point of light gradually becomes unmistakable, a second sun, still distant, yet steadily approaching. Imagine standing upon that ancient frozen world. For generations, your ancestors have known only darkness. Stories speak of a forgotten age when the sky was bright. Few believe those legends. Then, one evening, a brilliant new star appears. Each year it grows larger, each century brighter. Eventually, shadows return to the landscape for the first time in perhaps billions of years. The ice begins reflecting pale golden light. Mountains that had vanished into darkness slowly emerge once more. The world experiences its first sunrise in ages, not because its original star returned, but because another traveler happened to pass nearby. Of course, nearby in astronomy still means an extraordinary distance. Even the closest stellar encounters are measured in trillions of kilometers. Yet stars are astonishingly luminous. A close pass by a neighboring sun could dramatically increase the amount of energy reaching a frozen world. Perhaps not enough to melt entire oceans, but enough to awaken change. Surface ice might begin sublimating directly into vapor. thin temporary atmospheres could form. Frozen carbon dioxide trapped beneath the surface might burst into great plumes. Ancient glaciers could slowly soften around their edges. The world would begin breathing again, only briefly. Imagine what that must look like from orbit. For billions of years, the planet has appeared as a silent white sphere drifting through darkness. Then slowly, tiny patches of darker ice appear. Mist rises into the thin atmosphere. Faint clouds begin forming. The transformation unfolds so gradually that no single observer notices it happening. Yet after thousands of years, the difference becomes unmistakable. A sleeping world is waking. Perhaps the most fascinating possibility involves life. If microscopic organisms somehow survived beneath underground oceans throughout the long frozen age, additional warmth near the surface could create entirely new habitats. Meltwater pools, temporary rivers, thin lakes resting atop ancient glaciers. Life, if present, might cautiously expand upward for the first time in unimaginable ages. An entire biosphere responding to the arrival of a distant star. Not because the planet moved, but because the galaxy itself rearranged the heavens. Sadly, such awakenings would almost certainly be temporary. Stars continue traveling. The visitor eventually begins moving away. Its warmth slowly diminishes. The temporary atmosphere freezes once again. Surface water returns to ice. Darkness gradually reclaims the landscape. The second sunrise becomes the second sunset. The long winter resumes. Yet the planet has changed. Even a brief period of warmth measured in tens of thousands of years, a fleeting moment by cosmic standards, may leave lasting scars across the landscape. Ancient riverbeds, fresh mineral deposits, new layers preserved within the ice. Future explorers might one day discover those clues and realize that the world experienced not one lifetime, but many, separated by billions of years of silence. There is something deeply poetic about this possibility. On Earth, we often think of seasons as annual events. Spring follows winter, summer follows spring. The rhythm repeats every year. Elsewhere in the galaxy, seasons may operate on incomprehensible scales. A winter lasting 3 billion years, a spring lasting 50,000, then another winter. Not because the planet itself changed, but because the stars continued their slow journey through the Milky Way. It reminds us that time wears different faces depending on where you stand. A human lifetime, the age of a civilization, the lifetime of a star, the orbit of a galaxy. Each feels immense from its own perspective. Yet the universe quietly embraces them all. Perhaps somewhere tonight, beyond the reach of our telescopes, a frozen planet is witnessing the earliest moments of such an awakening. A distant star has begun climbing into its sky. The first gentle warmth touches ancient ice that has not felt sunlight since before Earth was born. No one is there to celebrate the moment. No civilization records the event. The planet simply responds as planets always have, patiently, silently, faithfully following the timeless laws of nature. And perhaps that is one of the most comforting lessons the cosmos offers. Even after billions of years of darkness, even after endless winters that seem as though they will never end, sometimes all it takes is the quiet arrival of a single distant star. To remind an entire world what sunrise feels like once again, 9. The impossible mountains taller than planets. Some alien landscapes may contain mountains so enormous that, on Earth, they could stretch beyond the edge of space. Mountains have always inspired a special kind of wonder. They seem permanent, unmoving, almost eternal. For thousands of years, people have climbed them in search of adventure, wisdom, or simply a better view of the world below. The highest peak on Earth, Mount Everest, rises nearly 9 kilometers above sea level. Standing at its summit, you are so high that the horizon curves gently away beneath your feet. The air becomes dangerously thin. the sky darkens into a deeper shade of blue. For centuries, it felt as though humanity had reached the roof of the world. Surely, nothing larger could exist. But the universe has never paid much attention to what we consider large. Beyond Earth are landscapes where mountains make Everest seem almost insignificant. Volcanoes so immense that they dominate entire planets. Cliffs stretching for thousands of kilometers. Frozen ridges taller than anything our world could ever support. And perhaps, some places where mountains rise so high that they almost seem to challenge the boundary between a planet and space itself. At first, this sounds impossible. How could any mountain grow so tall without collapsing beneath its own weight? On Earth, gravity constantly pulls downward. Every grain of rock, every layer of soil, every cliff face. The taller a mountain becomes, the greater the force trying to flatten it. Eventually, gravity always wins. The rock begins to crack, slopes collapse. The mountain slowly sinks under its own enormous mass. Earth itself quietly limits how tall its mountains can become. Nature, however, enjoys changing the rules simply by changing the planet. Imagine visiting Mars. At first glance, the red landscape appears strangely familiar. There are deserts, canyons, volcanoes, dust storms sweeping across the horizon. But hidden among those dusty plains stands something almost beyond belief: Olympus Mons, the largest volcano ever discovered in the solar system. Its summit rises roughly 22 kilometers above the surrounding landscape. Nearly 3 times taller than Mount Everest when measured from its base, its width is even more astonishing. Olympus Mons stretches nearly 600 kilometers across. Standing on one edge, you could not even see the opposite side, because the curvature of Mars itself would hide it beyond the horizon. It is less like climbing a mountain, and more like climbing an entire country. The slopes are surprisingly gentle. In many places, they rise only a few degrees. A traveler could spend days walking upward without realizing they were ascending one of the greatest mountains in the solar system. There is no dramatic peak suddenly appearing above the clouds. Instead, the climb is so gradual that only careful instruments would reveal the extraordinary elevation being gained. Why could Mars create something Earth never could? The answer lies in a quiet partnership between gravity and geology. Mars possesses only about 38% of Earth's gravity. Its rocks weigh less. The enormous volcano experiences far less downward force. Nature can therefore build upward much longer before collapse becomes inevitable. There is another reason as well. Here on Earth, our continents are constantly moving. The planet's crust is divided into massive tectonic plates that slowly drift across the mantle. Volcanoes form above regions where hot material rises from deep below. As the plate moves, the volcano gradually drifts away from its source of magma. New volcanoes eventually appear elsewhere. The Hawaiian Islands are beautiful examples of this process. Each island marks where the Pacific Plate once passed over a deep volcanic hotspot. Mars appears very different. Its crust has remained largely fixed for billions of years. The volcanic hotspot beneath Olympus Mons stayed in the same location while lava continued erupting again and again. Layer upon layer accumulated, century after century, million year after million year. The mountain simply kept growing, patiently, quietly, almost endlessly. Imagine standing near its summit. The horizon would appear astonishingly distant. Because Mars itself is smaller than Earth, the curvature feels more pronounced. Above you, the sky takes on a dark reddish-purple color, fading almost into black. The atmosphere is so thin that daylight seems strangely muted. Dust devils dance across distant plains far below. Clouds occasionally drift beneath your elevation. You are still standing on the planet, yet the edge of space suddenly feels surprisingly close. Now imagine worlds even smaller than Mars, tiny rocky planets where gravity is weaker still. Could mountains become even taller? Perhaps. Although other factors eventually impose their own limits, lower gravity allows landscapes that seem almost impossible by Earth's standards. Towering cliffs, immense volcanic shields, gigantic impact rims surrounding ancient craters. Every planet writes its own geological story. Ice worlds may be stranger still. On moons such as Saturn's Enceladus or Jupiter's Europa, the crust consists not of ordinary rock but frozen water. Ice behaves differently. It flows very slowly over long periods, almost like an incredibly thick liquid. Entire mountain ranges may gradually soften and reshape themselves without ever melting. Imagine enormous ridges of brilliant white ice reflecting distant sunlight beneath a black sky filled with stars. Not frozen forever, but moving so slowly that one human lifetime would never notice. Then there is one of the most dramatic landscapes known anywhere in the solar system, Verona Rupes, a cliff on Uranus's moon Miranda. Its height is estimated at around 20 kilometers. Standing at the top would be unlike standing atop any cliff on Earth. Here, a fall from such an unimaginable height would end almost instantly. On Miranda, gravity is so weak that the descent could take many minutes. You might even survive with the right equipment. Gravity changes everything, not only mountains, but danger itself. As astronomers continue discovering distant exoplanets, they naturally begin wondering what kinds of landscapes may exist there. Could a rocky super-Earth possess mountains taller than Olympus Mons? Perhaps not. Greater gravity would make towering peaks increasingly difficult to support. Instead, heavier planets may develop broader, flatter mountain ranges compressed beneath their own immense weight. Yet lighter worlds, especially those with unusual geological histories, may surprise us in entirely different ways. The universe has demonstrated again and again that it enjoys exploring every possibility permitted by physics. Perhaps somewhere there exists a planet whose crust is unusually strong, whose gravity is unusually gentle, whose volcanic activity persisted for billions of years without interruption. Such a combination could produce landscapes beyond anything we have yet imagined, not because nature broke its own rules, but because it followed them with extraordinary patience. Imagine flying above one of those alien worlds. At first, the mountains resemble ordinary ranges stretching across the horizon. Then, you realize something astonishing. The peaks continue rising long after you expected them to end. The atmosphere gradually grows thinner. The sky darkens. The stars begin appearing even while the landscape remains brightly illuminated below. For a brief moment, it feels as though the mountain itself is reaching into space, not quite crossing the boundary, but gently touching its edge. What would weather look like there? Perhaps clouds gather halfway up the slopes, leaving the summit permanently above the atmosphere. Perhaps snow never falls because the air has become too thin to carry moisture. Perhaps the highest peaks experience conditions unlike anywhere else on the planet. Tiny isolated islands between the world below and the emptiness above. Civilizations living on such a world might build legends around those unreachable summits. Ancient stories often describe mountains as bridges between Earth and the heavens. On another planet, that idea might feel remarkably literal. Climbing the tallest peak could mean ascending beyond the clouds into a sky where stars remain visible even at midday. The journey would become not merely an expedition, but a passage between two different worlds. There is something quietly humbling about mountains. Whether on Earth or on distant planets, they remind us that time builds slowly. No mountain appears overnight. Every layer records another eruption, another earthquake, another collision, another age of wind and ice. Their greatness is measured not only in height, but in patience. Perhaps somewhere tonight, beneath an unfamiliar constellation, an impossible mountain continues rising exactly as it has for billions of years. No one has climbed it, No footprints mark its slopes. No names have ever been given to its towering cliffs. It simply stands in silence beneath an alien sky, shaped by gravity, time, and the quiet determination of a universe that never seems to tire of creating landscapes grander than imagination. And perhaps that is one of astronomy's gentlest lessons. The farther we explore, the more we discover that the universe does not need to ignore the laws of physics to create wonders. It simply gives those laws enough time, and they quietly build mountains that seem impossible until the moment we find them. 10. The quiet planets between the stars. Not every lonely planet wanders forever. Some may drift peacefully through the empty space between neighboring stars for unimaginable lengths of time. When we imagine a planet, we almost instinctively imagine a sun. A warm star rising every morning, day followed by night, seasons quietly marking the passage of years. It feels impossible to separate the two. Stars create planets, planets orbit stars. That is simply how the universe works. Or so we have long believed. Yet, the Milky Way continues offering gentle reminders that nature rarely confines itself to our expectations. Some planets have no permanent sunrise, no familiar constellation, no parent star guiding their endless journey. Instead, they travel alone. Not in panic, not in chaos, but with remarkable patience, drifting through the immense darkness that separates one stellar neighborhood from the next. To us, interstellar space often sounds empty, a vast, silent void where absolutely nothing happens. In reality, it is astonishingly large. The average distance between neighboring stars is measured not in millions of kilometers, but in trillions. Even light, the fastest thing in the universe, requires years to cross those enormous gaps. Imagine shrinking the sun to the size of a tennis ball. Earth would become a tiny grain of sand several meters away. The nearest star? It would still be hundreds of kilometers distant. Most of the galaxy is not made of stars, it is made of space. And within that immense quiet, some planets wander. Astronomers call many of these worlds rogue planets. Most likely, they were not born alone. Like Earth, they probably began life inside ordinary planetary systems. Young stars are busy places, giant planets migrate. Smaller worlds collide. Gravity constantly reshapes the architecture of newborn systems. Occasionally, one unfortunate planet experiences a close encounter with a larger neighbor. A single gravitational nudge changes everything. Instead of settling into a stable orbit, the planet is accelerated. Its path stretches farther and farther from its sun. Eventually, it reaches escape velocity. There is no dramatic explosion, no violent farewell, only a quiet departure. One orbit becomes longer than the last. Then, almost imperceptibly, the planet simply never comes back. Its sun gradually shrinks into a brilliant star behind it. Centuries pass, then millennia. Eventually, the former home star becomes indistinguishable from countless others scattered across the heavens. The planet is alone, yet perhaps alone is not the right word, because even in interstellar space, gravity never truly lets go. Every star in the galaxy exerts a tiny pull. Every passing cloud of gas contributes ever so slightly. The wandering planet continues following the invisible currents of the Milky Way. Its journey resembles a leaf floating along a slow-moving river. The destination is unknown. The motion is gentle. There is no urgency, only time. Imagine standing on the surface of such a world. At first, the darkness feels overwhelming. There is no sunrise waiting beyond the horizon, no warm daylight, only an endless canopy of stars stretching in every direction. Without the glare of a nearby sun, the universe reveals itself with breathtaking clarity. The Milky Way no longer appears as a faint band across the sky. It dominates the heavens. Millions upon millions of stars become visible. distant galaxies emerge as delicate spirals of light. Nebulae glow softly against perfect darkness. Ironically, a world without a sun might offer the most spectacular night sky imaginable. It would never truly be night, because there would never truly be day. Time itself becomes strangely difficult to measure. On Earth, we organize our lives around sunrise and sunset. Days, months, years. A rogue planet possesses none of these familiar rhythms. Without a star to orbit, the concept of a year simply disappears. If the planet still rotates, there may be alternating periods of darkness and slightly different darkness. If tidal forces have slowed its rotation, one spin might require months or centuries. Perhaps it no longer rotates at all. The sky remains almost unchanged for generations. Calendars lose their meaning. Only the patient movement of distant stars reveals that time continues flowing. The cold would be extraordinary. Surface temperatures might plunge hundreds of degrees below freezing. Nitrogen could solidify. Carbon dioxide would become dry ice. The atmosphere, if one remained, would be thin and quiet. Yet appearances can be wonderfully deceptive. Deep underground. The story may be very different. A planet does not instantly lose all its warmth when it loses its star. Its interior continues generating heat. Radioactive elements slowly decay. The immense pressures left over from planetary formation still release energy. If the planet possesses a thick enough atmosphere or an insulating layer of ice, that precious warmth may remain trapped beneath the surface for astonishing lengths of time. Some scientists have proposed that rogue planets with dense hydrogen atmospheres could even maintain liquid water on their surfaces despite drifting through interstellar space. The atmosphere would act almost like an enormous blanket, preventing internal heat from escaping too quickly. Others may hide vast underground oceans beneath kilometers of frozen crust. Earth itself offers surprising examples. Life thrives around deep-sea hydrothermal vents where sunlight has never reached. Entire ecosystems survive using chemical energy rising from Earth's interior. The sun plays no direct role. Perhaps similar environments could exist beneath the frozen shells of wandering planets. Life, if it ever emerged, might continue quietly for billions of years without ever seeing a sunrise. Imagine an ocean sealed beneath endless ice. Above it, silence. Below, warm currents slowly circulate through the darkness. Simple organisms drift peacefully through black water, illuminated only by faint geothermal glow. They have never known the stars, never imagined daylight. Their universe consists entirely of hidden seas beneath an eternal winter. It sounds almost like science fiction, yet the laws of physics allow such possibilities. The universe often proves stranger than imagination because it never tries to be strange. It simply follows its own rules with extraordinary consistency. Over unimaginable stretches of time, a wandering planet may approach another stellar neighborhood, not close enough to collide, merely passing nearby. For perhaps a few thousand years, another sun grows brighter in its sky. Ancient ice reflects unfamiliar light. A temporary dawn visits a world that had forgotten daylight. Then, just as quietly, the star slips away once more. The darkness returns. The planet continues drifting, its journey never truly ending. The Milky Way itself becomes its home. Perhaps billions of years from now, some rogue planets will eventually be captured by entirely different stars. Gravity occasionally performs such delicate acts. A lonely traveler may wander close enough to a new stellar system that its path bends permanently. A second home. A second beginning. Imagine the first sunrise after billions of years. The frozen horizon slowly brightens. Shadows appear where none have existed for ages. Ancient glaciers sparkle beneath fresh sunlight. The planet, silent for eons, once again belongs to a star. Such events must be incredibly rare. Yet, Given enough planets, enough stars, and enough time, the galaxy has countless opportunities to perform even its rarest dances. There is something deeply peaceful about these wandering worlds. They remind us that not every journey requires a destination. Some paths simply continue, not because they are lost, but because motion itself has become their nature. They are travelers in the truest sense, carrying their histories quietly through the darkness between suns. Perhaps somewhere tonight, beyond every star we can see, one of these lonely planets is continuing its endless voyage. No civilization watches its passage. No astronomer records its position. It simply glides through the silent ocean between neighboring stars, accompanied only by gravity, time, and the distant glow of galaxies. And perhaps that is one of the gentlest images the universe offers us. Not every lonely world is searching for somewhere to belong. Some have already found their place in the quiet spaces between the stars. 11. The last planets to see. The end of the galaxy. When almost every star has faded into darkness, a few distant worlds may still witness the final glow of the Milky Way. Tonight, the universe feels wonderfully alive. The Milky Way contains hundreds of billions of stars. Some are only beginning their long lives. Others are quietly approaching their final days. New stars continue forming inside vast clouds of gas and dust. Supernovae briefly outshine entire galaxies. Planets circle their suns. Galaxies slowly dance around one another. Everything feels full of motion, full of light, full of possibility. It is difficult to imagine that this brilliant chapter will not last forever. Yet, the universe is patient, far more patient than we can truly comprehend. Every star is quietly spending a limited supply of fuel. Some burn through it rapidly, living only a few million years. Others sip their energy so slowly that they may continue shining for trillions of years. But eventually, even the longest-lived stars must change. The great story of starlight is not endless. It simply unfolds on timescales so vast that human history occupies less than a heartbeat. Imagine traveling unimaginably far into the future. Not thousands of years, not millions, not even billions. Imagine trillions upon trillions of years have passed. Earth is long gone. The sun exhausted its hydrogen long ago, expanding into a red giant before shedding its outer layers into space. The beautiful blue planet that once carried oceans and forests has either been consumed or transformed beyond recognition. Every civilization that ever existed has become part of an ancient history almost impossible to remember. Even the constellations themselves have vanished. The sky no longer resembles the one we know tonight. Stars have spent countless ages slowly moving through the galaxy. Many have already faded. Some have collided. Others have drifted away forever. The Milky Way itself has changed almost beyond recognition. Long before reaching this distant future, our galaxy will merge with the Andromeda Galaxy. The two enormous spirals will slowly intertwine over billions of years. At first glance, the collision sounds violent. In reality, space is so astonishingly empty that individual stars almost never strike one another. Instead, the galaxies gently pass through each other. Gravity reshapes their structure. The elegant spiral arms gradually disappear. A new, enormous galaxy slowly emerges. Astronomers sometimes call this future galaxy Milky. It will contain the stars of both galaxies woven together into one vast stellar city. For an unimaginably long time, that merged galaxy will continue shining. But eventually, even it must grow old. Star formation gradually slows. The great clouds of gas that once gave birth to countless new suns become increasingly scarce. Each new generation of stars consumes what remains. Little by little, the galaxy begins spending more light than it creates. The brilliant nights of cosmic youth quietly fade into calmer evenings. Imagine standing upon one of the last surviving planets, orbiting an ancient red dwarf. These tiny stars are remarkable. Unlike massive blue stars that burn brightly but briefly, red dwarfs consume their hydrogen with extraordinary patience. Some may continue shining for 10 trillion years or more. That is nearly 1,000 times longer than the sun's expected lifetime. If any planets remain around them, those worlds may become the final homes illuminated by ordinary starlight. Picture such a planet. Its sky no longer resembles ours. Most bright stars have already completed their lives. The heavens appear quieter, darker. The dazzling river of the Milky Way has faded into a softer glow. Entire regions once crowded with brilliant suns have become almost empty. The universe has not disappeared. It has simply grown older. The red dwarf above the horizon provides a gentle crimson daylight. Its warmth changes only slightly over unimaginable spans of time. Generations beyond counting could live and die while their little sun appears almost unchanged. To them, their quiet star would feel eternal. Yet even this remarkable survivor slowly approaches its own conclusion. Because eternity is something the universe never truly promises, astronomers believe that after the era of ordinary stars comes an age dominated by stellar remnants, white dwarfs, neutron stars, black holes. These are the quiet remains left behind after stars complete their long journeys. White dwarfs are especially fascinating. Although nuclear fusion has ended, they remain astonishingly hot. They simply cool very, very slowly. Imagine a glowing ember left behind after a great fire. Hours later, it still radiates warmth. Now imagine that ember requiring quadrillions of years to fade completely. That is roughly how patient the universe can be. Could planets continue orbiting such ancient remnants? Evidence suggests they can. Some already do. Over immense stretches of time, these quiet companions may become among the final planetary systems still holding together. No brilliant daylight remains, only the gentle warmth of fading stellar embers. If intelligent observers somehow lived upon one of these last worlds, astronomy would become an entirely different science. There would be few bright stars to study. Galaxies beyond their own might no longer be visible. In fact, due to the accelerated expansion of the universe, distant galaxies are gradually moving beyond the observable horizon. Light emitted from them today may never reach future observers. Eventually, civilizations living trillions of years from now may believe theirs is the only galaxy that exists. Not because others disappeared, but because the universe quietly carried them forever out of sight. It is one of the strangest consequences of cosmic expansion. The universe slowly hides its own history. Future astronomers may never realize there was once a Big Bang or countless neighboring galaxies. The evidence will have drifted beyond their reach. Knowledge itself changes with time. The sky remembers different stories depending on when you happen to be born. Yet, perhaps one final glow still remains. The combined light of ancient stars lingering near the galactic center, faint, gentle, barely illuminating the darkness. Imagine climbing a quiet mountain on one of those last planets. The air is still. Above you stretches a sky almost entirely black. Only a delicate ribbon of ancient starlight crosses the heavens. Not the brilliant Milky Way we know, but its final whisper. A galaxy remembering itself. There is something profoundly moving about that image, not because it is sad, but because it reminds us that endings are natural parts of every story. Forests become soil, mountains become sand, stars become white dwarfs, galaxies slowly exhaust their light. Nothing remains unchanged forever, yet neither does beauty disappear. It simply changes its form. The early universe dazzled with blazing newborn stars. The far future offers quieter wonders, ancient planets, fading suns, silent galaxies, different chapters, different kinds of beauty. Perhaps somewhere in that unimaginably distant future, the final inhabited planet, if any still exist, will look upward and see the last recognizable glow of its galaxy. Children there may ask whether the sky was always so dark. Elders may tell stories passed down across impossible stretches of time. Stories about ages when countless bright stars filled every corner of the heavens, when the galaxy shimmered like a river of diamonds. The tales may sound like myths, almost unbelievable. Yet they would be true, because every quiet evening begins as a brilliant afternoon, and every great story eventually becomes a memory. The remarkable thing is that the universe seems perfectly content with this rhythm. It does not rush toward its future. It unfolds one star at a time, one galaxy at a time, one unimaginable age after another. Perhaps that is why contemplating the far future feels strangely peaceful. It reminds us that existence is not measured only by beginnings. There is grace in endurance. There is beauty in persistence. Those final planets will not witness the end of the galaxy as a sudden catastrophe. They will experience it as the slow dimming of an ancient song that has been playing since nearly the beginning of time. And as the last faint glow of the Milky Way finally fades into the endless darkness, those quiet worlds may become the final witnesses to one of the greatest stories the universe has ever told. A story written not in words, but in stars. 12. The places humanity hasn't even imagined yet. Perhaps the strangest planets in the universe aren't the ones we've discovered, but the ones our imagination hasn't reached yet. For thousands of years, every world humanity knew was beneath our feet. The mountains, the oceans, the forests, the deserts. Beyond them stretched only mystery. Then came the telescope. Suddenly, the moon became another landscape. Jupiter revealed its giant storms. Saturn unfolded its magnificent rings. The universe grew larger, and with every new discovery, one lesson quietly repeated itself. Reality is almost always stranger than our expectations. No one imagined planets where iron rains from the sky. Yet they exist. No one expected worlds drifting alone between the stars. Yet astronomers continue finding evidence that they are surprisingly common. No one believed planets could survive around dead stars. Until they did. Again and again, nature has gently reminded us that the universe has never felt obligated to match the limits of human imagination. And perhaps that is the most beautiful discovery of all, because every astonishing planet we have found raises an even more intriguing possibility. What if the greatest wonders are still completely beyond our ability to imagine? Consider the history of astronomy itself. If you had asked an astronomer 200 years ago how many planets existed beyond the solar system, the honest answer would have been none that we know of. The very idea of other planetary systems remained almost entirely theoretical. Then, in the early 1990s, the first confirmed exoplanets were discovered. At first, there were only a handful. Soon there were dozens, then hundreds. Today, we know of thousands, each one quietly expanding the boundaries of what a planet can be. Every generation of telescopes has revealed something unexpected. Every improvement in technology has replaced certainty with curiosity. That pattern may never end. Imagine trying to describe the ocean without ever having seen water. You might invent rivers made of sand, mountains that flow, invisible valleys. Some guesses would accidentally approach the truth. Most would not. The problem would not be intelligence. It would be experience. Human imagination is remarkably powerful, yet it is quietly built from familiar pieces. Every mythical creature combines animals we already know. Every fictional landscape borrows from mountains, forests, rivers, or deserts we have already seen. Even our dreams usually rearrange reality rather than invent entirely new forms of it. The universe, however, has no such limitation. It is free to explore every possibility allowed by physics, not merely those we happen to imagine. Somewhere in the galaxy, there may already exist planetary systems unlike anything our language can adequately describe, not because they violate natural laws, but because they combine those laws in ways no human has yet considered. Perhaps there are worlds orbiting 3 stars locked in an intricate gravitational dance, planets whose seasons last longer than civilizations, landscapes shaped not by water or wind, but by entirely unfamiliar processes. Maybe somewhere, clouds are made of substances that never naturally occur on Earth. Perhaps rivers flow beneath transparent ice, beneath skies, illuminated by glowing rings. Maybe entire mountain ranges slowly migrate across the surface over millions of years, driven by forces we have not yet observed anywhere in our own solar system. Each possibility sounds extraordinary. Yet, history encourages humility. Many discoveries that once sounded impossible are now found in astronomy textbooks. Nature repeatedly demonstrates that imagination usually follows discovery, not the other way around. The James Webb Space Telescope has already begun revealing atmospheres unlike anything previously observed. Future observatories will peer even deeper. One day, astronomers may directly photograph Earth-sized worlds around distant stars. Later still, they may detect subtle chemical signatures hinting at weather systems, oceans, or perhaps even biological activity. Each new generation will inherit a larger universe than the one before. Imagine an astronomer living 500 years from now. They may browse catalogs containing millions of confirmed planets. Entire families of worlds may have names and classifications that do not yet exist today. Students might casually learn about planetary types that remain completely unknown to us. Just as modern children grow up knowing about galaxies, black holes, and exoplanets, ideas unavailable to earlier generations, future civilizations will likely inherit wonders we cannot yet imagine. To them, today's astronomy may seem wonderfully incomplete, not incorrect, simply young. There is something comforting about that. We often feel pressure to understand everything, to solve every mystery, to reach every answer. Yet the universe gently suggests another perspective. Perhaps knowledge is less like reaching the top of a mountain, and more like walking toward an ever-receding horizon. Every answer reveals new questions. Every discovery opens another door. Wonder survives because certainty never fully arrives. Even mathematics hints at this endless richness. The laws of physics allow astonishing diversity. A small difference in mass, a slight change in orbital distance, another nearby star, a different atmospheric composition. Tiny variations during planetary formation can produce completely different outcomes billions of years later. The universe behaves almost like a composer writing endless variations on the same musical theme. Every world follows familiar physical laws, yet no 2 symphonies sound exactly alike. Perhaps somewhere, there exists a planet where the night sky glows softly because microscopic crystals suspended in the atmosphere scatter distant starlight. Another may experience rain only once every 100,000 years. Another may possess oceans hidden entirely beneath floating continents of ice. Some possibilities may sound fantastical today. Tomorrow's observations may quietly reveal that they are real. Or perhaps reality will prove stranger still. There is another possibility, even more profound. Perhaps some of the greatest wonders are not planets at all. Maybe entirely new categories of celestial objects await discovery. Throughout history, astronomy has repeatedly expanded its vocabulary. First came planets, then galaxies, then neutron stars, quasars, pulsars, brown dwarfs, exoplanets. Every time scientists believed the cosmic inventory was nearly complete, nature introduced something unexpected. why should that process suddenly stop now? The observable universe contains roughly 2 trillion galaxies. Each galaxy contains billions or hundreds of billions of stars. The numbers become almost impossible to picture. If even a tiny fraction of those stars host planetary systems, then the number of worlds exceeds every grain of sand on every beach Earth has ever known. We have carefully studied only an infinitesimal fraction of them. Imagine standing on a shoreline and examining a single grain of sand, then announcing that you understand every beach on Earth. The comparison is almost laughably optimistic. That, in many ways, is where humanity stands today. Our knowledge has grown enormously, yet, compared with the universe itself, we have barely begun. Perhaps that realization is not discouraging. Perhaps it is deeply hopeful, because it means mystery is not disappearing. There will always be another horizon, another telescope, another discovery quietly waiting beyond the limits of our current understanding. Some child alive today may grow up to discover a type of world that no one has ever imagined. Another may give the first name to a planetary landscape unlike anything in science fiction. Someone centuries from now may gaze upon a sky we cannot yet picture and describe colors, seasons, or celestial rhythms that currently have no words. The future of astronomy is not simply about answering questions. It is about learning better questions to ask. And perhaps that is the greatest gift the universe offers. Not certainty, but endless curiosity. Tonight, as you look upward, remember that every star you see almost certainly has its own story. Many possess planets. Some of those worlds resemble places we already understand. Others almost certainly do not. Far beyond the reach of our strongest telescopes, countless landscapes continue existing without witnesses. Mountains no eye has ever seen. Oceans no map has ever traced. Skies no poem has ever described. They do not become less real because they remain unknown. They simply wait with the same quiet patience the universe has always possessed. Perhaps one day, humanity will find them. Perhaps we will not. Either way, they remind us that the cosmos is larger than our imagination. And that may be the most wonderful thought of all, because as long as there are places we have not yet imagined, there will always be another journey waiting among the stars. If this peaceful voyage across the universe helped end your day with a little more curiosity, consider subscribing, and I'll be here whenever you're ready for our next journey among the stars.